NASA admits its Mars orbiter captured unprecedented images of Interstellar Visitor 3D Atlas. Yet, as China releases a 302-frame sequence, those high-resolution HiRISE shots remain locked behind a bureaucratic freeze with planetary defense rumors swirling and scientists sounding alarms. Why is the most anticipated space data of the year still hidden? Inside the escalating pressure, silence, and the stakes for science, the truth behind this standoff is far stranger than it seems. Confirmation came swiftly. NASA officials acknowledged that the Mars Reconnaissance Orbiter HiRISE camera captured images of interstellar object 3D Atlas during its close approach to Mars on October 3, 2025. These images are real, not speculative, and their existence is now a matter of public record. For the first time, a spacecraft orbiting another planet trained its most powerful camera on an object from beyond our solar system, an astronomical milestone. Yet, while China's Tianwen-1 probe has already published a full 302-frame sequence of the encounter, NASA's images remain locked away, unavailable to the public or the global scientific community. Questions multiplied as word spread of the data freeze. NASA's explanation is procedural. The US government shutdown, which began on October 1st, forced most non-essential operations to halt, including the processing and release of scientific data. Under federal law, only activities directly tied to spacecraft health and safety could continue. Data from HiRISE, though safely stored, could not move through the usual chain of calibration, validation, and public posting. 4 weeks, the world waited as the images sat untouched in NASA's pipeline. Transparency became a focal point as competing agencies and international observers watched China move quickly to fill the vacuum. The China National Space Administration released its own Mars orbiter images of 3D Atlas showing a bright compact coma, a white dot with a faint halo captured from roughly the same distance as NASA's planned observations. Although the Chinese images are lower in resolution than what HiRISE can achieve, their rapid publication drew attention to the contrast in transparency and speed. Rumors of a planetary defense alert swirled online and in some media outlets. NASA has not issued any official warning or upgraded alert regarding 3D Atlas. The agency's public statements emphasize that the object poses no threat to Earth and that the focus remains on scientific discovery. The so-called maximum planetary defense alert appears to be unsubstantiated, fueled more by speculation than by any documented action from NASA's Planetary Defense Coordination Office. Pressure is mounting from multiple directions. US Representative Anna Paulina Luna has gone on record stating that NASA will release the HiRISE images once the government reopens and internal reviews are complete. Harvard astrophysicist Avi Loeb has sent open letters arguing that science depends on timely access to new data, especially when anomalies might challenge established theories. For now, the images remain under lock and key, their contents known only to a handful of mission staff. The world is left waiting as the stakes, scientific, political, and public, continue to rise. The machinery behind NASA's scientific data pipeline is built on precision, routine, and legal compliance. When the US government shutdown began at midnight on October 1, 2025, nearly all non-essential NASA operations were forced to stop. This was not a matter of choice or internal policy. The shutdown triggered federal law requiring that only activities necessary for the immediate protection of life, property, or national security could continue. For the Mars Reconnaissance Orbiter's HiRISE camera, that meant the spacecraft itself remained under constant monitoring, ensuring its health and safety. But the flow of new science data, including the highly anticipated images of 3D Atlas, ground to a halt. Methodical is the only way to describe the process for handling these images. After HiRISE captured its scheduled frames during the comet's close pass on October 2nd and 3rd, 2025, the raw data was stored on board the orbiter, then downlinked to Earth during routine deep space network passes. Normally, these files would be transferred to the HiRISE Operations Center at the University of Arizona, where a civilian team would convert the telemetry, calibrate the images, and run quality checks. From there, the science team would review the processed data, validate the results, and prepare them for public release. Each step is governed by strict protocols and each requires staff who during a shutdown are legally required to remain off duty unless specifically exempted. No part of this pipeline from raw data ingestion to calibration, validation, and final posting to NASA's public archives was classified as essential work. Waivers for exceptions are exceedingly rare, typically reserved for matters of national security or immediate risk, not for routine scientific observation. The only staff permitted to remain active were those responsible for spacecraft safety, not for data analysis or public engagement. Even the routine review and approval of images by NASA's Public Affairs Office was frozen. The shutdown's effect rippled out to public records requests as well. Freedom of Information Act queries, which often provide access to internal emails or mission logs, face their own backlog. No Freedom of Information Act release communications about the HiRISE 3.I Atlas dataset appeared in NASA's document repositories during this period, and the standard response time stretched even further as the shutdown continued. This procedural freeze is not unique to the 2025 shutdown. Past events, such as those in 2013 and 2019, followed the same pattern. Emergency releases of data only occurred when required for legal or safety reasons, never for general scientific interest. Without a presidential or congressional override, the rules are absolute. As a result, the HiRISE images, while safely stored and fully acquired, remained locked in the pipeline, untouched by scientists or the public. Until the government reopened and the full team could return to work, public pressure began to mount as the days stretched on without any sign of the HiRISE images. In Washington, Representative Anna Paulina Luna issued a clear statement. NASA would be expected to release the 3.I Atlas images as soon as the government reopened and the necessary internal reviews concluded. Her words echoed across science news outlets and social media, amplifying calls for accountability. Luna's demand was not just a procedural request. It was a signal that the image blackout had moved beyond technical delay and into the realm of public trust. She framed the issue as one of transparency, arguing that discoveries of this magnitude belong to everyone, not just the handful of officials who control the data pipeline. AVI Lowe took a more philosophical approach. Outside the halls of Congress, the Harvard astrophysicist, well known for challenging conventional thinking about interstellar objects, sent open letters to NASA leadership and to congressional committees. He argued that science depends on timely access to new data, especially when the evidence might reveal something unexpected. He wrote that science advances by pursuing anomalies that defy old paradigms and gathering new data. 3.I Atlas is a gift for discovery. For Lowe, the comet's long observable arc through the solar system was a rare opportunity, not just for scientists, but for the public and for students who might be inspired to ask new questions about the universe. Lowe's advocacy went beyond technical points. He drew a sharp contrast between what he called the humility to learn and the arrogance of expertise. In his view, openness is not just a courtesy but a core scientific value. He added, "If we want to make progress, we must be willing to admit what we don't know and let the evidence lead us." His message found a wide audience among journalists, educators, and citizen scientists who saw the 3-day Atlas episode as a test of whether big science institutions could keep pace with the public's appetite for discovery. Transparency campaigns multiplied. Advocacy groups and science communicators circulated petitions and open messages urging NASA to publish the images as soon as possible. Many observers pointed to China's rapid release of Tianwen-1 data as a contrast, arguing that United States leadership in space science depends on openness as much as technical prowess. Others warned that prolonged delays could fuel conspiracy theories or erode confidence in the agencies responsible for stewarding humanity's UNDIT. The stakes were no longer internal. The conflict over the HiRISE images now involved lawmakers, scientists, and a global audience invested in the outcome. Each new statement from Representative Luna or from Lowe added to the sense that the stakes were not just scientific but civic. The images themselves had become a symbol of transparency, of international rivalry, and of the public's right to witness the unfolding story of the third interstellar visitor ever recorded. In this climate, every day that the data remained locked away only sharpened the demand for answers. October 3, 2025 offered an observational opportunity. As 3.I Atlas swept past Mars at a distance of 29 million kilometers, the geometry placed the interstellar visitor within reach of some of the most advanced cameras sent beyond Earth. For HiRISE, the high-resolution imaging science experiment aboard NASA's Mars Reconnaissance Orbiter. This was a test of both engineering and timing. The camera had a 50 centimeters aperture paired with a 12 m focal length designed to resolve features on the Martian surface smaller than a meter across. But at tens of millions of kilometers, even HiRISE faced the